Now see this question, which of the following is not true? So out of these 4 options, we have to choose the option which is false. Now the first one is, if a relation capital R on a set capital A is symmetric and transitive, then it is reflexive. So it is a classic confusion. So whenever I take this in classrooms, many people will have doubts on this. Even after explaining everything, still they'll ask me the same doubt. So just try to pay attention here. If a relation capital R on a set capital A is symmetric and transitive, then capital R is reflexive. So they are saying that the relation is symmetric and it is transitive. So what does it mean? So what people think is, since it is symmetric, then it means that if A comma B is there, then B comma A should be there. And now they are saying that after it is symmetric, it is transitive as well. Transitive means since B comma B is present, then A comma A has to be present. And similarly, since B comma A and A comma B are present, B comma B has to be present. Therefore, if it is going to be symmetric and transitive, it is going to be reflexive. That is what people generally think, isn't it? Just think about it. So they are saying that if a relation on capital A is symmetric and transitive, then it is reflexive. And from this example, it is clear that it is reflexive. But we made a basic mistake there. So the mistake here is, if it contains A comma B, then only it contains B comma A, right? So if you should not miss that if case, which means a relation is symmetric only when if it contains A comma B, then it should contain B comma A. So there is no guarantee that there will be A comma B at all. For example, if you think that we have capital A equal to 1 comma 2 comma 3, then I will write a relation R equal to 1 comma 1. That's it. This is a relation which is symmetric because A comma B is present, B comma A is present, which is of course A comma A itself, and it is transitive, right? But it is not reflexive. Got it? Therefore, you have to pay attention there. If it contains A comma B, then only it should contain B comma A, isn't it? That is when we are going to test for symmetric. If it does not contain A comma B at all, then it is going to be symmetric. For example, the simplest relation is R equal to empty set. Empty set is both symmetric as well as transitive because it does not contain any elements of type A comma B. Therefore, you need not check at all. It is directly symmetric, and it does not contain any elements of type A comma B and B comma C. Therefore, you need not check for A comma C. It is directly transitive. So it is both symmetric as well as transitive, but not reflexive. So it is very, very important. You will get definitely confused here. Just by writing something like this, you will get confused. So think carefully here. If a relation R is symmetric and transitive, then it is reflexive. So this statement is false, clearly false. Okay, it need not be reflexive. Now the next one is, if a relation capital R on a set capital A is irreflexive and transitive, then it is antisymmetric. So they are saying that it is irreflexive, which means it will not contain any diagonal elements, and they are saying that it is transitive, which means if at all it contains A comma B, B comma C, it will contain A comma C. Then they are saying that it is antisymmetric. So now we shall see that we can prove it in many ways. So I'll try to prove in 1 or 2 ways. You to keep thinking about it. See, now they are saying that if it does not contain any diagonal elements, that is what is irreflexive is, and if it is transitive, then they are saying that it is antisymmetric. Why is it true or why is it false? Now let us assume that it is false. Okay, let us assume that this statement is false, which means if a relation is if a relation is irreflexive and transitive, then R is not antisymmetric. Let us assume that R is not antisymmetric. Then what happens? That is my assumption. If it is not antisymmetric, then what happens is A comma B and B comma A might be a pair which might be present in this relation R, which is causing it not antisymmetric. Now, since this is present in the relation R, and it is also already given that it is transitive. Because of the presence of these two elements, definitely a comma a will be present and b comma b will be present. Now if these two are present, now it cannot be irreflexive, but it is already given that it is irreflexive. Therefore our assumption is false. What is our assumption? My assumption is that R is not antisymmetric because of the presence of these elements, but since it is already given that it is transitive, these two elements should be present, which is causing R not irreflexive, which is false. Therefore it definitely should be antisymmetric. Or if you want to think about it in other way, you can think about it. See this. Okay, so I think this proof is fine, right? Or you can take with some examples and you go with that. Anyway, I think this proof is clear. Okay, next one is, if capital R and capital S are antisymmetric on a set capital A, then R union S and R intersection S are also antisymmetric, which means they are asking about the properties of antisymmetric relation. We have already seen it. Now if you have antisymmetric relation, we know that antisymmetric relations are closed under intersection. Therefore R intersection S is antisymmetric, it is fine, but then it is not closed under union. The reason is simple. If you have a relation A comma B, this is antisymmetric because it does not have symmetric pairs. If you have a relation B comma A, this is also antisymmetric, right, because it does not contain symmetric pair. When I take the union of this, they are going to introduce symmetric pairs. Therefore even though the relations are symmetric, antisymmetric individually, the union need not be antisymmetric. Therefore this is false, right? This is true. Now last one is, if capital R and capital S are transitive relation, then they are asking about the properties of transitive relation. So what do you know about transitive relation? Now since we didn't discuss about the properties of transitive relation separately, let me discuss about it here. Now if R is a transitive relation, what can you say about subset of R? Is subset of R a transitive relation? So what I mean to ask is, if I take a transitive relation and if I take a subset of it, is it going to be transitive relation? So what I mean to actually ask is, are transitive relations closed under subset operation? They need not be closed. The reason is simple. So you can take an example and you can work it out. Let us say a relation is like this: A comma B, B comma C and A comma C. These three ordered pairs are present in a relation. Okay, and now if you take a subset of it, which means if you skip one of them, let us say if I take a subset of this and eliminate this, the resulting is not going to be a transitive relation. Therefore we can say that this subset need not be transitive. So it is not closed under subset operation. What about superset operation? Is it closed under superset operation? Which means if I take a transitive relation, so in fact empty set is a transitive relation, and if I try to add some members, is it going to be superset? Is it going to be transitive? It need not be. For example, if you add A comma B and B comma C, this is enough that it is not transitive relation. Now what about, let's say if I have two transitive relations R and S, what can you say about R intersection S? Now let us see when R intersection S will not be transitive. R intersection S will not be transitive only when it contains two elements of type A comma B and B comma C, and if it does not contain A comma C, isn't it? Now how do you think we got A comma B and B comma C? Because they both were present in R as well as S. Now since R and S are individually transitive relations, definitely both of them must be containing A comma C, and so when I take the intersection along with this pair, I'll even get A comma C as well in the intersection. Therefore if these two are transitive, definitely intersection is also going to be transitive. Otherwise, one case is if these two doesn't contain A comma B and B comma C, we will not get them at all. Now in case if we get them in the intersection, definitely they are present in both these, and so both of them will also be containing A comma C. Got it? Now what about, so what can you say about it? Transitive relations are closed under intersection. What can you say about union? Which means if I have a transitive relation R and if I have a transitive relation S, is the union going to be transitive? Need not be, because you can take this example. Let us say A comma B is a relation. It is of course transitive, and let's say one more relation is B comma C. It is of course transitive. Now if I take union of these two relations, then we are going to get A comma B and B comma C, so which is not transitive. Got it? Therefore they are not closed under union operation. So they are closed under intersection, transitive relations, but not closed under subset or superset, or in fact union operation. Got it? So what is it they are saying? R intersection S is always transitive, true, but R union S need not be transitive. Yes, true. So D is true. So A and C are false and B and D are true. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.